Hello, welcome. Hearty welcome to you. So, we are going through matrices, and in this session, we will try to understand what's the meaning of transpose of a matrix. So, to understand transpose of a matrix, let us consider a simple matrix. How we denote a matrix? We denote the matrix by capital alphabet. So, we'll say A is equal to, let us take a simple example. Let us say 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that this is a matrix. Now, can you tell me what are the rows of this matrix? The rows are, this is the first row, and this is the second row, and this is the third row. Similarly, what are the columns? This 1, 4, 7 is in first column, 2, 5, 8 are second column, and 3, 6, 9 are third column. Now, if I interchange the rows as columns, that means the first row is 1, 2, 3. Now I make it as first column. I will write 1, 2, 3. The second row 4, 5, 6. I will write it as second column. Now the third row I will make it as third column. Now this matrix, whatever you got, the resultant of interchanging the rows and columns, is called as the transpose of a matrix. And the transpose of a matrix is given by either A to the power of t or A to the power of, that tells us that it's a transpose of a matrix. Very simple concept. There is nothing in it, right? What you have to do, if you interchange the rows and columns of a matrix, then it is called as a transpose of a matrix. Okay. Now let's try to understand what are the properties with respect to the transpose of matrix. The properties are, number 1. If you take a transpose of a matrix and you again transpose it, that's nothing but equal to the matrix itself. It's very clear, simple, easily evident. You take a matrix, you transpose it, again you transpose it. Now suppose I transpose this matrix, what happens? The column should become row. That means 1, 2, 3 will be my first row. 4, 5, 6 will be my second row. 7, 8, 9, which is third column here, should become third row. And that's nothing but equal to A. So you can say A transpose is nothing but equal to A. Not only that, we also know that if you have a constant k, you multiply with A and the transpose everything, that's nothing but equal to k into A transpose. That also we know. Let's go to the one more property. The property is, if you have two matrices A and B and you try to find out the transpose of it, that is nothing but equal to individually summing up the transpose of those two matrices. So A plus B transpose is nothing but equal to A transpose plus B transpose. And finally, the most important one is, if you have two matrices A, B and you multiply them, then you do transpose, that's nothing but equal to B transpose into A transpose. We will take a simple example and see how this works out. Okay, that's about the transpose of matrix. Before we go into problems, the theory concept is, if you take a matrix and interchange its rows and columns, then it is called as transpose of a matrix. Some properties of transposing of matrices. One is, if you transpose and again transpose the same matrix, whatever the matrix you got, it will be nothing but equal to the original matrix. If I take a matrix A, transpose it, and again transpose it, then it's nothing but equal to A. And also, if you want to add two matrices and transpose it, that's nothing but equal to individually transposing the matrices and summing them up or adding them. The last and final important one, if you multiply two matrices and take a transpose of that, find out the transpose of that matrix, it's nothing but equal to product of B transpose into A transpose. If you are going for AB transpose, that's nothing but equal to B transpose into A transpose. Now what we will do, we will look at couple of definitions, types of matrices. Let us say that they are called as symmetric matrix. One is symmetric matrix. The next one is skew symmetric matrix. What's the meaning of them? Skew, first is symmetric matrix. The next one is skew symmetric matrix. What's the meaning of that? Is if a matrix is called as a symmetric matrix if A transpose is equal to A. If you are transposing a matrix but still you have the same matrix, then it is called as symmetric matrix. On the other hand, what is skew symmetric matrix? If transpose of a matrix is nothing but equal to negative times the matrix, then it is called as skew symmetric matrix. Let's try to put down some examples for this. Okay, let us do one example for symmetric matrix. Okay, let us do that. Okay, right. Now let us say 1, 2, 3. This is the row. If you convert this column, this is the first column, it should become first row. So 1, 2, 3. Then I have 4, 5, 4, 5, 6. Now you can check this. If I make a transpose of this, it will be the first row will become first column. This is A. If I say A transpose is nothing but equal to first row to be first column, that is 1, 2, 3. Second row to be second column, that is 2, 4, 5. And third row to be third column. So it's nothing but 3, 5, 6. Now see what is that? It's nothing but equal to 1, 2, 3, 2, 4, 5, 3. This is nothing but equal to this. That's why it's called as symmetric matrix. Well, let's look at one example of skew symmetric matrix. Yes. Let us take a matrix by saying 0, 1, 2, minus 1, minus 2. Then you have 0, you have 4, you have minus 4, you have 0. Let us say this is the matrix A. 0, 1, 2, 0, minus 1, 0, 4, minus 2, minus 4, 0. Now let us try to take a transpose of this. What is the transpose of this? First row should become first column. So 0, 1, 2 will become first column 0, 1, 2. Second row will become second column, that is minus 1, 0, 4. And what is the third row? The third row should become third column. That means minus 2, minus 4 and 0. Now if you see the relation between these two, you can see very clearly this is nothing but equal to minus of A, because minus of A minus 0, minus 1, minus 2, minus 1, 0, 4, 2, 4, 0. So you can see A is nothing but equal, A transpose is nothing but equal to minus of A. That's why it is called as a skew symmetric matrix. That's about the transpose of matrix. It's very important concept. Let us try to do one simple example to understand. Let's take this one, AB whole transpose equal to B transpose into A transpose. Let us see how that works out with the help of a simple example. We will do that in just 1 minute. So we have looked at the theory concept now. What's a transpose to summarize, and what are the properties. We also learned about symmetric and skew symmetric matrix. In the next video or the next session, we will go through one example and that. Okay, because we are crossing 10 minutes. Thanks for visiting. Bye for now.